Hi, welcome. We are doing notes 7-6 today, which is page 27 in your note guides. Hopefully everybody has them. Today we're going to be talking the date. Next week will be about 2021. Non-isosceles trapezoids. We're going to talk about non-isosceles trapezoids first. These are quadrilaterals that are not parallelograms. So we talked about parallelograms, rectangles, rhombuses, squares. Those are all parallelograms with special features. Today we're going to talk about non-isosceles trapezoids. Trapezoid only has one pair of opposite sides that are parallel. That's all you need to be a trapezoid. Now, the other thing that happens here is that the consecutive angles are going to be supplementary. So not congruent, but between parallel lines, these angles right here, not congruent, but they're supplementary, which means they add up to 180 degrees. Now, isosceles trapezoids mean that two sides are going to be congruent. It's not the parallel sides, it's the other sides are going to be congruent. Now, if the other sides are congruent, I have all the things that I know here that are going to take place. I know that these angles are going to be supplementary, and these angles are going to be supplementary. They're going to have to be congruent, because if these are the same, the opposite angles have to be congruent there. Non-parallel sides are congruent, diagonals are congruent, base angles are congruent, so these two are the same and those two are the same, and they add up to 180. Diagonals being congruent, but they're not cut, they're not bisected. So this piece here would be the same as this piece here, and this piece here would be the same as this piece here. Opposite angles are supplementary. If the consecutive angles are supplementary, the opposite angles are also supplementary. So these are things we know. Now, that's all you need to be able to answer all of these questions. We're going to have a lot of algebraic expressions, algebraic equations where it's 1-2 multi-step equations. That's what we're doing today. Answer any of these that you can. If this is 87, this is 51, well, these two have to be supplementary. So I can do 180 minus 51. I end up getting 129 degrees. Now 87 and m have to be supplementary. 180 minus 87, I end up with 193 degrees. Same thing, do this one over here. I'll come back and check your answers in a moment for you. I'm going to go to 3. Now on 3, these are the parallel lines. These are the consecutive angles. Sometimes I like to turn my paper around so I see the parallel on top and bottom. And this one's a tricky one. It doesn't look like a regular trapezoid. Sorry. But it is. These have to be supplementary. So I'm going to take 54 plus 8x plus 6. Add those together. Supplementary is 180. I end up with 8x plus 60 equals 180. Subtract the 60, so I'm going to get 8x equals 120. And now I divide by 8. Okay, I don't see evenly exactly what it goes into. You can use your calculator to divide. I'm going to divide both of those by 2. If I divide both by 2, I get 60 over 4. I know how many times 4 goes into 60. If I don't, I could still simplify and get 30 over 2. And now I know for sure that it's going to be 15. You can do that a lot of different ways, but I think simplifying, reducing that fraction is kind of the easiest. Go ahead and do this one. I'll come back and check it with you in a moment. Now 5 here, isosceles trapezoid. DG is going to be equal to, well, this is an isosceles trapezoid, DG has to be the same as EF over here. Line segment EF. Now DF is this diagonal. DF is going to have to be congruent to this diagonal. I'm going to call it EG. There we go. Go ahead and name this one over here. This down here. Now, isosceles trapezoid. If this is 112, these have to be the same. This would be 112. So I'm not even looking here for a minute. I also know that these have to be supplementary. So 180, oh, that it's messy. I'm trying to be quick because I know you guys like faster videos, and you can pause. So 180 minus 112, 8. I get 68 here for this angle here and this angle here. So Q is 112. Don't forget your degree symbol. R is 68. And S is the same, 68. I'm going to go back and give you the answers to these and do this a little bit faster even. C has to be supplementary to 31. Subtract from 180. I would get 149. D, subtract from 180. 180 minus 60 minus 2, I get 118. Do you have any questions? Again, come by our office hours and I will do any of these much slower for you if you have a question or want me to do it after class as well. These two have to add up to 180. 12x plus 3 plus 7x plus 13 equals 180. Get 19x plus 16 equals 180. Oh, no, I don't. That's a negative 13. Be really, really careful with your signs. That's a negative 13. So 3 minus 13 is going to give me a negative 10. Oops. So I get 19x equals 190. X here equals 10. Now it asks me to solve for r, so I'm going to plug that in. I get 70. 7 times 10 is 70 minus 13, giving me 57 degrees for angle R. Again, slow this down, pause it, work with them out on your own. These ones here, T has to be congruent to angle U. V has to be congruent to angle W. Here, if this is 47, I get 47 here. Subtract from 180, I get 133 for these ones. So W is 47 degrees, 133, 133. I'm going to pause and go to the next page. The next page, immediately reading this, we should notice isosceles trapezoid is important, which means these two sides, MP and NO, are going to be congruent. So I can set up 16x minus 13, set it equal to 9x plus 8. I also know that PN and MO, I know the values, and if I look, those are the diagonals. The diagonals have to be congruent. So we can set 5y plus 19 equals to 12y minus 37. Now again, I'm going to pause and I'm going to work it out and show you the answer in a minute. So pause, work it out first. Probably know by now I definitely like to color code, so if you have color, orange and green highlighters, that's what I'm going to use on this page a little bit. Subtract over here, I got 7x. Add 13, I got 21. Here I subtracted 5y and I added 37. I got 8 equals y, or y equals 8. Here, isosceles trapezoid, opposite angles are congruent. I'm going to set those two orange angles equal to each other and solve. Go ahead and do that and I'll be back in a minute. So a reminder here, I didn't do it up here, I kind of forgot, but here I chose to put the 5x first, because then when I subtract the 2x over, I have my x over here on the left, which I prefer, because then I don't have to swap it. Divide by 3, I got 13. Now, I need to find the angle measure, so I plugged it into the 2x plus 27, because it was just smaller, and I got 53. So my orange angles are 53 degrees, and now they're supplementary, so I do 180 minus the 53 degrees, and I end up with 127. Okay, so down here, again, isosceles trapezoid. So I know it's isosceles, which means I know this angle and this angle match, this angle and this angle match. So I can't set them equal this time. This time I have to add and set them equal to 180. I'm going to do 10x minus 33 plus 4x plus 17 equals 180. I end up with 14x. Negative 33 plus 17, I get negative 16, equals 180. 14x equals 196. Divide by 14. Now again, you can, well, hopefully you see this one. That's a perfect square. X equals 14. If you don't see it right away, you can always divide by 2. You get 93 over 7, and 7 goes over 14. Anyway, 14. This is asking for the actual angle measures though, so you got to plug it in. 10 times 14 is going to be 140. Minus 33 is going to give us 107. That's my green angle. So the green angles here are going to be J and K. Those are 107. If I subtract 180 minus 107, I end up with 73 degrees for my orange angles, which are going to be L and M for 73. So just kind of color code so you can see what's going on and where those numbers are coming from. Go ahead and take a minute and work this one out. I'm going to pause, then I'll come back and set it up for you. And knowing that they're different colors, you automatically or immediately see that they're not equal. So if we know that they're not equal, I'm going to have to add them together. So I have the 6x minus 1 plus the 10x plus 5 equals 180. I'm going to pause again, and I'll be back in a minute, so go ahead and work that out on your own and come back and check. Hi. Okay, so here are our answers. I solved, I got 11, plugged it in, and got 115 and 65. Now I'm not going to work out completely 13 and 14, but I am going to pause and then I'll show you what the answers are. So if you want to work those out, you can. Another thing with these types of problems that is helpful is just looking at them. I know that this is a cute little angle, and this is one of the big angles. It's an obtuse one, so there's no way they can be equal. So if you see visually that this one's small and that one's big, you can't set them equal. They've got to add up to like 180 or 90 depending on what the problem is. These ones, those are both the big angles, they're going to be the same. These are both the small angles, they're going to be the same. So even if you don't memorize the rules, you can look at it, kind of figure it out. What does it appear to be? What appears to be happening with the problem? So go ahead and check those and do that. I'm going to go to the next page. We're going to do mid-segments, and I think that's it for, well, pretty much it for 7-6. We're going to do mid-segments of a trapezoid. This is 7-6 still, same set of notes, so we're going to go on a little bit more. Still going to use my orange and green. I have a parallelogram. These two sides are parallel. AB is parallel to DC. And a mid-segment cuts it. It's the midpoint of the side. Right here, that's our mid-segment. So if EF is the mid-segment of trapezoid ABCD, then I know that AB is parallel to CD is parallel to EF. I know that all three sides are parallel, and I know that EF, because it's right in the middle, it's going to be the average. Remember, average is when you add two numbers and divide by 2. So it's going to be the average of AB and CD. You're going to add those two numbers together and divide them in half. Just take the average. So here, you don't have to draw this, but I color-coded these so we can see these down here because I'm using this picture for these problems. So I have AB here and DC here, AB here and DC here. Oh, this time I have DC here and EF. AB here and EF. So these ones are going to be a little bit different. Just going to point that out a little bit. Well, you definitely want to pay attention to what they give you in the problem. All right. So here I want to find EF. I'm going to add 14 plus 26. Divide by 2. I'm going to get 40. Divide by 2 equals 20. Come back and work that one out for you in a minute. Now this one's going to be a little bit backwards. AB is my question, so I'm going to put an X here. Plus 38, if I divide it by 2, it would be equal to 22. So you add the 2, that's your AB, which is your variable. So this and 38, divide by 2, equals this. Color coded also, you kind of see where it's coming. Now, what I'm going to do is I'm going to just multiply both sides by 2 here to get rid of that fraction. I have x plus 38 equals 44. I'm going to subtract 38. So when I subtract 38, I end up with x equals 6. Over here, when you do these ones, hopefully you did these ones already, pause, make sure you get the right answer. 7 plus 31 divided by 2, 38 divided by 2 equals 19. Here again, I have 41 plus my missing value is my x, divided by 2 equals 47. I'm going to multiply both sides here by 2. I end up with 41 plus x. 47 times 2 is 94. Subtract 41, I get x equals 53. So good job there. Hopefully you guys got those right. This one's going to be a little bit trickier. These are our bases. Here's what the middle should be. Okay, so this one's a little bit more work, not much. We can do this. Same process. I'm going to take x plus 14 plus the 38, divide by 2, and it will equal 5x minus 19. So again, I'm going to multiply both sides here by 2 to get rid of that. But I have to remember what's the trickiest thing here is when I multiply by 2, I've got to distribute this. So don't forget to distribute. X, 14 and 38 is going to give me 52. 2 times 5 is 10x. 2 times 19 is negative 38. Now my x is on the wrong side, that's fine, but I don't like it over there. I'm going to add 38 over here. I get 90. Subtract x, I get 9x. Divide, I get x equals 10. Well, it's asking me to find yz. Well, yz is this one right here. So if I'm finding yz, I'm going to plug it in. 5 times 10 minus 19. 50 minus 19, I get 31 degrees for my answer. There we go. Take a minute. This one's very similar. I'm going to pause and then I'm going to work them out so you don't have to watch every step. Okay, so here are the final 2 answers. Oh, my picture's in the screen there. This one over. There you go. One thing I did, I put a degree here, and that's not an angle. This should not have a degree. So kind of fix that there. But those are the last 2 answers. If you have a question, please come see me. All the work is there. Hopefully you guys are catching on to that. Now, there was one last page, 476, that I kind of want to discuss. I didn't really do anything for this page, but it's a reference page you might want to have handy. So remember, I've told you before that on the edge, put something else under the edge, and if you highlight, that will stick out in your note guide and will be easy for you to find. So it's something you want to do. This is all of our quadrilaterals that we've discussed. I'll raise this a little bit. So parallelograms, all the properties of parallelograms, rhombi, rectangles, squares, trapezoids, isosceles, trapezoids. You might want to go through and put markings on them. If there's any markings you want to remember, I might pause it and do that for you. These are definitely not all the markings that we could put on there, but they are quite a few. So, and the ones that I don't think we're familiar with are the angles. So I wanted to make sure we put a lot of those in there. So there you go. There's your quadrilaterals and parallelograms. And good luck. Have a fabulous day. I will see you guys next time.